Okay, get this. Robots are, like, terrible at lifelong learning.
Mm-hmm.
You practically have to wipe their memory banks clean every time you want to teach them something new.
Yeah.
It's like they have amnesia,
Right.
But what if we could change that? What if we had robots that could learn and adapt just like we do?
Yeah.
Building on their knowledge instead of constantly starting from scratch.
Right.
That's the kind of radical idea we're diving into today.
Okay.
And by the way, if you're enjoying these deep dives into the future of AI, hit that subscribe button to help us keep bringing you more.
Yeah, this is a fascinating challenge.
Yeah.
This research is tackling a really fundamental problem in robotics.
Okay.
Catastrophic forgetting.
Right.
Most robots today are like specialists, great at one task, but they're prone to forgetting everything they know when they learn something new.
It's like they're stuck in a perpetual loop of robot kindergarten.
Yeah, exactly.
So how do we get them out of robot kindergarten?
Well, this research takes inspiration from how we learn.
Okay.
Specifically, our ability to remember past experiences to solve new problems.
Right.
So this new approach,
Yeah.
it's called retrieval-based weighted local adaptation.
Retrieval-based weighted local adaptation.
It gives robots a sort of episodic memory, a library of past actions, and observations tagged with visual and language cues.
So it's like giving the robot a mental scrapbook.
Yeah, that's a good analogy.
Okay.
Filled with memories that it can flip through.
Uh-huh.
So just like you might search your own memory for a similar situation when you're facing a new challenge,
Right.
this robot can search its memory bank for relevant experiences.
Okay. I like it.
Let's say the robot needs to learn how to stack blocks in a new configuration.
Okay.
It can search its memory for instances where it's manipulated blocks before,
Okay.
even if the arrangement was different.
Gotcha.
It then uses those memories as a starting point, adapting and fine-tuning its actions based on the new scenario.
That sounds way more efficient than starting from scratch every time.
Right.
But wouldn't constantly tweaking the robot's core programming lead to problems? I mean, imagine if every time you learned something new, your brain got slightly rewired.
Yeah.
It sounds like a recipe for disaster.
You've hit on a really crucial point.
Okay.
The researchers address that very concern.
Okay.
To prevent what we call catastrophic forgetting, they created a clever workaround.
Okay, let's hear it.
For each new learning scenario, the robot generates a temporary copy of its brain.
Okay.
This temporary copy is what gets fine-tuned and adapted,
Gotcha.
leaving the core knowledge base untouched.
Ah, so it's like having a scratch pad for each new lesson.
Yeah, exactly.
You can scribble all you want without messing up your permanent notes.
Right.
I'm starting to see why this is such a big deal.
Yeah.
Okay, but let's get down to brass tacks.
Uh-huh.
How well does this actually work?
To test their approach, the researchers used a platform called the Libero Benchmark.
The Libero benchmark. Okay.
It's specifically designed to evaluate lifelong robot learning and involves various manipulation tasks,
Okay.
like picking up and placing objects with different shapes and sizes.
Okay.
It's a great way to see how well a robot can learn and adapt in a more complex,
Yeah.
less predictable environment.
So it's not just about memorizing a sequence of steps.
Right.
Yeah. The robot has to actually understand what it's doing and apply its knowledge to new situations.
Exactly.
What were the results?
The results were impressive.
Give us the highlights.
This new method significantly outperformed other approaches to lifelong robot learning,
Okay.
particularly when task boundaries were blurred.
By blurred, you mean?
Imagine the robot is used to stacking blocks in a neat, organized way.
Right.
Now, suddenly, the blocks are scattered randomly,
Okay.
and it has to figure out how to adapt its stacking skills to this messier,
Yeah.
more realistic scenario.
I gotcha.
That's where this method really shines.
So it's not just about rote memorization.
Nope.
The robot is actually able to generalize its knowledge
Right.
and apply it to new situations.
Right.
That's a huge leap forward.
It is.
But I imagine there are still limitations, right?
Of course.
Real-world scenarios are way more chaotic than even the most complex lab setup.
Every groundbreaking technology has its limitations.
Right.
We'll definitely delve into those.
Okay.
But what's remarkable is that even when the robot retrieves slightly inaccurate memories, think of it like pulling up a fuzzy memory from your own past, it was still able to adapt and learn effectively.
Okay.
This suggests the system is quite robust and potentially generalizable to a wide range of situations.
Okay, now that's impressive.
Yeah.
But hold on, before we get too carried away,
Okay.
let's unpack this weighted part of retrieval-based weighted local adaptation.
Okay.
It sounds intriguing.
It is.
What's the deal with weighting those memories?
It's all about efficiency. Think about how you learn you don't give equal weight to every piece of information you encounter. You focus on what's relevant, especially when you're trying to improve a skill. Remember that time you tried baking a cake?
Oh, yeah.
And it totally flopped.
It was a disaster.
I bet you paid extra attention to the steps you messed up on the next time you tried.
Oh, absolutely.
Yeah.
That cake was a culinary disaster.
But
I definitely learned from my mistakes.
exactly.
So how does the robot decide which memories to prioritize?
Well,
Does it have a tiny robot chef judging its performance?
not quite a robot chef,
Okay.
but the concept is similar.
Okay.
The weighting process is based on the robot's errors.
Okay.
When it attempts a new task, it analyzes its performance,
Right.
paying close attention to where it goes wrong. Then when it searches its memory bank, it gives more weight to the memories that address those specific errors.
So instead of treating all its memories equally,
Right.
it's like the robot is highlighting the most important parts of its experience.
Exactly.
Like studying smarter, not harder.
Yeah.
This all ties back to the human element we were talking about, doesn't it?
It does.
We're wired to remember things that are important for our survival.
Right.
And this research is taking advantage of that same principle.
Exactly, by selectively weighting its memories.
Yeah.
The robot can quickly fine-tune its skills without wasting time on things it already knows how to do well.
Right.
It's a targeted approach to learning.
This is incredible.
Yeah.
But let's shift gears a bit.
Okay.
We've talked a lot about the technical details,
Mm-hmm.
but what about the bigger picture?
Sure.
What are the real-world implications of this technology?
Okay.
I mean, beyond just stacking blocks, of course.
If we connect this to the bigger picture, the possibilities are pretty mind-blowing.
Okay, give us some concrete examples.
Think about manufacturing.
Okay.
Imagine a factory where robots can quickly learn new assembly procedures on the fly,
Uh-huh.
adapting to changes in product design or customer demand,
Right.
or in healthcare.
Okay.
Robots could assist surgeons with complex procedures. Okay.
Learning and adapting to each patient's unique anatomy in real time.
Wow. We're talking about robots that can essentially learn and grow throughout their lives,
Yeah.
constantly expanding their capabilities.
Yeah, it's almost like science fiction becoming reality.
But let's be real, this is still research, right?
Of course.
What are the limitations?
Uh,
What are the researchers still trying to figure out?
of course, there are always challenges to overcome.
Right.
One key area for improvement is the selective weighting process.
Okay.
Right now, it works well in controlled lab settings.
Right.
But real-world scenarios are far more complex.
Sure.
It can be tricky for the robot to pinpoint the exact moment where things go wrong
Uh-huh.
and then correlate that to the relevant information in its memory.
Okay.
Imagine a robot trying to navigate a busy street.
Okay.
There are so many variables.
Right.
Pedestrians, traffic lights, unexpected obstacles.
Yeah, all kinds of things.
Isolating the precise moment where a mistake occurs is a complex problem. And robots don't experience the world in the same way we do.
Right.
Their actions are often a series of complex movements and calculations.
Exactly.
It's not as simple as a human saying, oops, I dropped the ball.
Yeah.
So how are the researchers planning to address this challenge?
They're exploring ways to make the robot's error detection more precise and nuanced.
Okay.
This might involve incorporating additional sensors to gather more data about the environment,
Okay.
or developing more sophisticated algorithms to analyze the robot's actions and sensory input.
Gotcha.
It's like giving the robot a sharper set of senses and a more analytical mind to better understand its own mistakes.
That makes sense.
Yeah.
It sounds like there's still a lot of work to be done,
Yeah,
but the potential here is incredible.
it is.
But before we wrap up, let's give our listeners a quick recap of the key takeaways from this deep dive.
Okay.
What are the most important things to remember about this groundbreaking research?
Absolutely. Let's distill those key insights.
Okay.
First, we have to acknowledge the elephant in the room.
Traditional robots are terrible at lifelong learning.
Yeah, they are.
They struggle with what we call catastrophic forgetting, where learning something new can wipe out previously acquired knowledge.
Right. It's like their little robot brains have a limited capacity for knowledge.
Okay.
But this new research offers a potential solution by equipping robots with a form of episodic memory,
Right.
similar to what humans have.
Exactly. And this is the second key takeaway.
Okay.
This retrieval-based approach, called retrieval-based weighted local adaptation, enables robots to access relevant past experiences to adapt to new situations quickly.
Okay.
It's like having a vast library of experiences to draw from,
Right.
allowing them to build upon their knowledge rather than starting from scratch every time.
Yeah, and to top it off, they're not just randomly sifting through their memory banks.
Right.
This is where the weighted part comes in.
Exactly.
By focusing on their mistakes, robots can learn more efficiently.
Yes.
Prioritizing the information that truly matters for improvement.
It's like having a personal tutor, highlighting the key areas where you need to focus your efforts.
Exactly. And the implications of this, our third takeaway, are huge.
Okay.
This research holds immense potential for real-world applications across numerous fields.
Okay.
From revolutionizing manufacturing processes with adaptable robots
Right.
to enhancing healthcare with robots that can assist surgeons with unprecedented precision and adaptability.
This has been an incredible deep dive into the future of robotics.
It has.
We've gone from robots stuck in perpetual kindergarten to robots capable of continuous learning and adaptation.
Right.
But as with any emerging technology, it's crucial to acknowledge both the potential and the limitations.
Right.
While this research shows immense promise, it's still early days.
Yeah.
Refining the robot's ability to pinpoint errors in complex environments and translating these findings into practical applications will be key challenges for the future.
That's a crucial point. While the research is incredibly exciting, it's important to remember that we're still in the early stages of exploring this type of learning in robots.
Yeah.
But that's also what makes it so fascinating.
Right.
We're on the cusp of a new era in robotics, one where robots can learn and adapt alongside humans, constantly evolving and expanding their capabilities.
It really is mind-blowing to think about.
It is.
And here's a final thought for our listeners to ponder.
Okay.
If we can achieve this level of continuous learning in robots, what's next? Could we apply these same principles to other forms of AI,
Yeah.
pushing the boundaries of what AI can achieve?
It's a good question.
It's a question that I, for one, can't wait to see answered.
It's a question that will undoubtedly fuel countless innovations and discoveries in the years to come.
Yeah.
The future of AI is filled with possibilities,
Right.
and this research is a tantalizing glimpse into what might be possible.
Thank you for joining us on this incredible journey into the world of lifelong learning robots.
It's been a pleasure.
Until next time, keep those brains buzzing.